Hello everyone, welcome to Legacy IAS. This is our first video on time, speed and distance. Now, time, speed and distance. You already understand these terms. Time is time, speed, speed, distance is distance. Okay. One very basic formula is that you all know is speed is equals to distance upon time, or distance is equals to speed into time, or time is equals to distance upon speed. These are the three basic formulas, correct? Now, time, speed and distance. Now, another term that you might have seen a lot in questions is relative speed. Now, what is relative speed? The relative speed, let's say there are two cars. So, this is car 1 going in this direction. Now, this is car 2 going in this direction. Now, or yeah, going in this direction. Now, see this. This is a car going in this direction. This is a car going in this direction. Let's draw this also far. So this is a car going in this direction. Now you tell me, if these are the two cars, now they're both approaching each other. So whatever is the distance between this car, whatever is the distance between these two cars will be covered by what velocity? Let's say this is going at speed of v1 and this is going at speed of v2. Velocity, speed same here. So it is going at speed of v1, this is going at speed of v2. Now how much time will it take to cover this distance? Now you can see that both of them are moving towards each other. That is, both of these speeds, or the motion of this car is getting combined to cover this distance. That's why time is equals to, time will be what? Distance apart, time to meet. In how much time they will meet? So this will be distance apart upon divided by the relative speed. Now, relative speed in this case will be what? Because they both are working together to cover this distance. So, in this case, time will be equal to whatever is the distance d and the sum of their speeds, that is v1 plus v2. Now, in the other one, now they are moving in the same direction. Now, if d is the distance between them, now this car is going away or increasing this car is increasing the distance between them. Let's say this stops here, okay, this becomes stationary, then this d will keep on increasing because of, let's say this is because of the speed of first one. Now this will keep on increasing. Now if this stops right here, then can you see that this d will decrease with speed of the second vehicle, correct? With v2 speed it will keep on decreasing. So this is trying to decrease the distance. Here this is also trying to decrease the distance, this is also trying to decrease the distance. That's why they got added. Here this one is trying to decrease the distance, but this one is trying to increase the distance. That's why they will be subtracted, as you will see. So the time taken for them to meet will be equal to, again, distance apart upon the relative speed. Distance apart is what? D. Relative speed will be what? Difference of these two. That is V2 minus V1. Correct? Because this only is trying to reduce the distance or cover the distance. That is just increasing the distance. So I have subtracted this. Now, one more thing you can observe here, that if the velocity of the first one, if the velocity of or the speed of first one is greater than the second one, then what will happen? This will keep on going very fast, this is much slower. So this will leave, and the one that is behind will not be able to catch it ever. That is why the time of their meeting will become what? If you put it here, if v1 is bigger than v2, what is the time of meeting? You will get something in negative. That is, they will never meet, because time cannot be negative. So this also is getting satisfied by this. Understood? So if one thing you have to remember, in all of this relative speed concept is this. It's this. That is, time taken to meet will be equal to distance apart upon relative speed. That's it. Then let's get to questions. Okay, what it says? It says a bus is moving with a speed of 30 km per hour. A car is chasing it with a speed of 50 km per hour. Okay, so bus. This is bus. Bus is moving at 30 kilometers per hour. Now, car is chasing it at 50 kilometer per hour. Correct. Now, how many kilometers apart are they if it takes 15 minutes for the car to catch the bus? Formula is the same, that is time taken to meet or to catch whatever is equals to distance apart divided by relative speed. Now, as you can see, this is trying to increase the distance, this is trying to decrease the distance, correct? So relative speed will be negative when they are moving in same direction. When two objects are moving in same direction, relative speed comes out to be something like this in subtraction. When they are moving in opposite direction, relative speed is comes out to be something addition. So this is relative speeds. Now, distance apart is what? What is the distance between them? We don't know. This distance only we have to find. Let's say this is d upon. What is the relative speed? 50 and 30. Going in the same direction, 50 minus 30, that is 20 kilometer per hour. Now, next is this is equal to what? Time is given to you. Time is given to you as 15 minutes. But here the speed is in kilometer per hour. It is in kilometer per hour. Now, that 15 minutes you cannot put directly here as 15. You have to convert it into hour. That is 15 minutes means what? 50 by 15 by 60, or simply 1 by 4 hour. Anyway, you can write 15 by 60 hours. How many times this will go? This will go one time, this will go 4 times, then one time, this will go 5 times. What you got? You got d is equals to 5 kilometers. That's it. So the distance came out to be 5 kilometers. Okay, so that is the distance between them is 5 kilometers, and then it will get covered. It will get covered in 15 minutes. Understood? Then next. Then let's do this. A cyclist A starts down the road at a speed of 15 km per hour. Cyclist B starts at 20 minutes later from the same spot at a speed of 20 km per hour. B will overtake A after how many hours? Now, see, initially A and B are at same place. Then, cyclist A starts down a road at a speed of 15 km per hour. So, A starts going at 15 km per hour. Then a cyclist B starts 20 minutes later. 20 minutes later, cyclist B starts. Now, see the other scenario. So B is still here. This is after 20 minutes. B is still here at the starting point. A has reached where? We don't know. But this is somewhere A. Correct? Now, A is at what distance? First of all, this is important. So A goes at what speed? A starts with a speed of 15 km per hour, travels for 20 minutes. So in 20 minutes, if it goes 15 km in 1 hour, in 20 minutes, how much it will go? It will go 5 kilometers, or just calculate it. So 15 kilometer per hour is the speed. The distance I have to calculate how much has A traveled by there. So distance is equals to speed into time. Time is what? 20 minutes. 20 minutes means what? 20 by 60 hours. Hours cancel. What you got? 15 into 1 by 3. Correct? Or 5 kilometers. So this comes out to be 5 kilometers. Now, Now you see, now B will also start moving. B moves at what speed? B moves at 20 km per hour, and A continues to move at 15 km per hour. Okay, understand? Understand this, that you can make a note point that we calculate distance apart and relative speed only at the time both objects start moving, not before that. So first thing is when they both start moving. Right now A is moving, but B is still in its place. So B is not moving. So we cannot take the distance apart, relative speed, nothing here. When A reaches 5 km, now B starts moving. So now we will take this distance and now we'll take the relative speed. Okay. So now formula is same. Time is equals to distance apart divided by relative speed. Distance apart is what? What is the distance between them? Right now, when they both start moving, 5 kilometers. So this becomes 5 km upon. Relative speed is what? What is the relative speed between them? Relative speed is 20 and 15. That means they're moving in same direction. So it will be subtracted. 20 minus 15 is 5 km per hour. So time taken will be what? 5 and 5 cancel out. It will go above. So this becomes time is equals to 1 hour. Now, B will overtake A after how many hours? So what you got? It will overtake A in 1 hour. That's it. So what's the answer you got? You got 1 hour. Simple. Simply you have to calculate you have to first make sure that both the objects are moving. Once both start moving, then you calculate the distance apart and then you take the relative speed between them. Distance apart upon relative speeds gives you whatever time will be taken. Okay, that's it for this class. Next we'll see in the next part. Thank you.